Okay, we're going to just talk about how to calculate the mass of Jupiter based on the orbit of its moon Io. So Io orbits Jupiter with an average radius of 422,000 kilometers. There are 1,000 meters in a kilometer, so if you multiply by 1,000, canceling out the units of kilometers, you get 422 million meters, or 4.22 E8. That's times 10 to the power of 8 meters. That's the average orbital radius of Io from the center of mass of Jupiter. It takes about 1.769 days to complete one complete revolution. So that's its sidereal period. And when we use this period value, we want to convert it to seconds. So multiply by 24 hours in a day to cancel days, 60 minutes in an hour to cancel hours, and then multiply that by 60 seconds per minute to cancel minutes. That leaves you at 152,842 seconds. Rounded to 3 sig figs, that's 1.53 times 10 to the 5th seconds, or 1.53 E5. Now, those values I plugged into this chart. We got the radius of Io, the period of Io, and when you substitute that into Newton's form of Kepler's third law, that's all you need to know, the radius and period of any orbiting satellite to determine the mass at the center of that orbit, and that will allow us to solve for the mass of Jupiter in units of kilograms. So as long as we start with the SI units of meters and seconds, we end with the SI units of mass for kilograms. You do so by getting this constant, 5.92 times 10 to the 11th, times the radius cubed divided by the period squared. So what I will be doing is just simply substituting that into my TI Nspire calculator. Please do so as well. And the trick is just to enter the values properly. It's easy to make a couple mistakes entering. Here we go. I have a little screen in the backdrop. First things first. Let's enter our constant. This is 4 pi squared over g, which reduces to 5.92, rounded to 3 sig figs. Press the double E button. That means it looks like a double E on your calculator, but it shows up as a capital E, which represents times 10 to the power of 11 in this case. You're going to multiply that by the radius, 4.22 times 10 to the 8th, so E8. Raise that to the third power, that's cubed. And then you're going to take that quantity. You could just press enter, whatever that number is, and then divide it by period squared. 1.53 times 10 to the 5th. Remember, raise that to the second power. You can see it took that number divided by the period squared and rounded to 3 sig figs. This would be 1.90 E27, which is 1.90 times 10 to the 27th, which is very close to the accepted value for the mass of Jupiter. If you're not careful with your notation, sometimes a common problem with using your calculator is it doesn't use the order of operations properly, and that's why it's important to use the E notation. So if I take the constant times the radius cubed, 4.22 E8 raised to the third, you can do it all in one step. There's the problem though. When you hit divided by, it's dividing the power, so you have to be a little careful. So once you do this, you can just press to the right, get your regular screen, divide that quantity by whatever your period is, 1.53 E5. Now some people hit the square power or raise to the second power. Same thing. If you press enter, you know you did it right because you can see how it grouped the values. It has your constant times the radius to the third power divided by your period to the second power, and you get the same value. Try the same process for the rest of the problems.